So now how do we generate the video textures of the dynamic regions? Again, those pixels that were just the dynamic parts of the image are the ones now we're going to figure out how to basically convert them into video textures. So just to kind of start thinking about it, I'm now laying out this whole thing, and I'm basically kind of saying is this is the y-axis and this is x and this is time. So basically now we're going to stack each and every of these images in time and just show the x and t. So as time evolves, of course, we're getting more and more of these frames. So in this case, I'm basically kind of saying is this is one frame, second frame, third frame, and all of them kind of create this video volume, right? But let's think about it a little differently. And that basically suggests is let's actually only concentrate on the dynamic regions. So here, this part of the frame, not the whole frame, this is the only part of the frame where there is some dynamics. And again, as I go down in time, there are other frames come in. Remember, again, this is similar to the whole part that we looked at before, which said that if I had an image like this, there's only a part of this image where the dynamics is. So in essence, that basically means if this is my x, I'm going to be only looking for small parts in that image, not the whole part. And in this case, I'm basically kind of suggesting for each and every image in the region, only a part of it is the one that is where the dynamics is. And as I move further into time, this part may have moved here. And that's where I have other frames. So in essence, this is the only part of the dynamics that I actually want to model. So how do we use that information? Well, for example, what we can now start doing is build video textures just for those small regions. So in essence, what that basically means, this is where the video textures, I don't have to actually do it for the whole part of it. I can find a sub part of this region and use that to generate a video texture. So the video volume in this instance would simply be in time and in the local coordinate x, simply a part like this. So this would be my small video region. And again, I have well-defined slits here. So this allows me to create now a smoother transition from each and every one of the frames and generate a nicer, smoother video volume to represent this region here. So in this case, what we basically says, we're going to map the continuous diagonal slice of the input video volume to the output panorama. That's what we actually will do, and outputting the video textures onto a panorama again in that region where the dynamics are. Of course, in this case, we will restrict the boundaries to each and every frame. So each and every frame basically is kind of looking at just that frame, and we're going to find a match to the next frame. And the problem with this is, while it works fine, actually creates some sort of shearing motions across time. Now remember, we actually had these issues when we talked about video textures too, when we basically said match one frame to the other. And of course, either you'll get a little bit of blurriness because it has not the best match, or you might actually see unnecessary motions that are impacted because how things are matching from one frame to the other. What does that mean? Well, let's look at that example. This is my original video frame or sequence just from the part where the water flow is happening in approximately the same region, where we basically are now doing a continuous diagonal slices. So here's my original video. You kind of see nicer motion. And here you basically see a little bit of shearing going on. Motion is not the most cleanest, and in fact basically takes the first frame and actually generates it because it's not actually doing a very good job on generating the video volume. It's actually keeping the boundaries stable.